So today on Chronic Whimsy, we'll be discussing the physics of freefall. Yay! Daily we party, each one day a week, Chronic Whimsy. As you can see, I got a whiteboard for this one because it makes it a lot more fun to explain. Now, say one day you decide to go up in an airplane, very badly drawn here, and there you are standing at the door, and there's a bunch of sky. Not water, it's sky. See? Sky for emphasis. Now, let's say you decided to be crazy enough and stand at the edge of the airplane, and then you decide to jump out. Whee! Here you go. There you are, your feet and hands out, and your little parachute, and there goes the plane plummeting towards ground. Yay, smiles and hair for emphasis that you're falling. Now, the important thing is you'll be falling at about terminal velocity. Now, sorry if the spelling's bad, but terminal velocity is about 120 miles an hour and is usually reached at about 4,500 feet minimum. So here are three drawings. One is face on, one is a bottom view, and the other one is side on. Now, if you look at the side on, you'll see the blue dots that represents the airflow, and it kind of looks like a candle. Now, if you were to look at the bottom view, you'll see that the person is symmetrical. Now, if I was to take that arm and extend it out, that would disrupt the airflow uneven on one side, and that would create what is known as drag. Now, drag is bad when you're free falling because it causes your body to spin around in the direction of the red arrows, and that's bad. Now, let's take a look at the reason why we arch. You'll see here is what we call the center of mass. It's where your hips push out, and it gives you that nice arch shape. The reason we do that is, here's an experiment you can do at home as to why. Here's a bit of paper and here's a ball of paper. If you were to drop these at the same time, the ball of paper would hit the ground first and the paper would just float down. And the reason that is because the ball has a center of mass. It has a point where it's all weighted, and obviously the airflow works better. And the reason why we do this is so we have this nice arch and airflow can go around. Now, if you were to arch the other way, as shown in this badly drawn diagram, your center of mass is still at your hips, but what happens is the airflow builds up, and then what happens is you known as de-arches when your body flips round. Now, this is bad when you're free falling, and the best way to demonstrate this, imagine if a shuttlecock, badly drawn here, has a center point where that black weight is. If you were to throw that up in the air, what happens is it reaches a high point, it levels off, and then with the weight at the bottom, it flips down, and that's what happens to your body when you arch the other way, is that you automatically de-arch, so you get that nice round arching flow. And this is self-correcting. You do this while free falling, just like shuttlecocks do. And that has been physics of free fall. Yay! And now you get to see a badly drawn thumbs up. If you like this drawing, or if you like this video, please give it a thumbs up. If you want to, subscribe to Chronic Whimsy, where you can see more interesting videos from us, and comment below of any future themes you'd like to see. I'm Yoon, and peace out.